Welcome back to 11.2, and we're talking about length versus area versus volume. So a difficulty with understanding whether to measure a length, an area, or a volume is that many objects have parts and different dimensions. So let's talk about a balloon for an example. So if we were talking about the outside surface, it's two-dimensional. But if we were talking about the air inside, that would be three-dimensional. And then we've got the circumference of a balloon, which is the length of an imaginary one-dimensional circle drawn around it. And so we've got all these different parts. So the size of each of these parts should be described in different ways. We've got the air in the balloon for volume, the surface of the balloon for area, and their circumference for length. So another example in which the same object has different parts of different dimensions is the Earth. If we think about the inside of the Earth is three-dimensional, the surface is two-dimensional, and the equator is a one-dimensional imaginary length. So we can describe the Earth in different ways by volume, area, and length. So let's do an example. We're going to describe the one-dimensional, two-dimensional, and three-dimensional aspects of a water tower. And so some towns have water towers for distributing water. So in each case, name an appropriate U.S. customary unit and an appropriate metric unit for measuring or describing the size of that part or aspect of the water tower, and the practical reasons for wanting to know the size, parts, or aspects. All right, let's start with the one-dimensional. So that would be like the height of the water tower. And that's going to be measured in feet or meters, right? We're not going to measure that in inches. And who would want to know that and why? Well, some towns might want to limit the height, right? If they've got rules, you don't want like a huge water tower. Maybe you do, and you're going to put an advertisement or the name of your town. But we might want to know it for limiting the height when we design it. All right, let's look at two-dimensional. So this might be the surface area of the water tower. And that would be in square feet or square meters. And why might we want to know this? Well, what if we want to know how much paint to cover, right? We got to determine maybe the cost of the paint, or how many painters we need, or how many gallons to buy. All right, so now let's talk about three dimensions. Well, this is the water inside. That's very important, right? This is a measurement of the water inside. And this could be cubic feet or cubic meters. Or we don't really say cubic meters. We would say gallons, like I said earlier, or liters. I mean, we could say cubic meters, but that's not a very common one. It's not wrong, but it's just not very common. So we want to know, obviously, how much it will hold. Because we want to know when we need more, will we have enough? And so here it is all written out nicely for you. Let's do another example. So let's describe, and so instead of something in a real world situation, let's describe these boxes here, these three-dimensional shapes. So we want to describe the 1D, 2D, and 3D aspects of the blocks, and we want to compare the size of the blocks using an appropriate unit, and then we're going to use this unit to show that each block can actually be considered the biggest of the three. All right, let's start with one-dimensional. So that is going to be our height, our width, our depth, or the perimeter of one face, right? All of those are one-dimensional aspects. So height, length, or width, whatever language you want to use, depth, and perimeter. These are all examples of one-dimensional. And this would be the perimeter of one face, right? Just the area, the length around one face. And so if we wanted to know what was how it could be the biggest, let's look at the height, because I can see that green one is really tall. So if we went by height, then the green is the largest. Green is biggest, I think is the language they use, right? Because it is 7 inches versus 1 inch versus 3 inches. So I've shown that one's the biggest. Okay, now let's look at two-dimensional. So two-dimensional could be the area of one face, or the overall surface area. Could find the area of all the faces and add them together. So if I just look at like a bottom face of each of these. Okay, so bottom face of each of these. So this green bottom face would be a 1 cubic inch, 1 by 1. The orange one would be a 5 by 5, right? That would be 25 cubic inches. 5 by 5. And this one would be 9 cubic inches. So the orange one is the biggest, if we look at that aspect. And then now let's look at 3D. So now we're talking about volume. So, well, volume, I'm going to multiply. So that's going to be 1 times 1 times 7, right? Because how many cubic inches will fill this? I'm going to have 7, right? So that would be 7 cubic inches. And then here, I'm going to say, okay, I've got a row of that 25, but I only have 1 row. So that's going to be 25 cubic inches. And then this one is 3 by 3. So that's 9 cubic inches, but I'm going to stack it 3 high. So 27 cubic inches. So the blue is the biggest. So I've described each of these in their dimensional aspects and used them to show that they could all be considered the biggest. And there it is written out for you. And go ahead and give this one a try. Press play when you're ready to see the solution. And that concludes 11.2.